Yeah, hi, my name is René. I work at 5 Minds. We are a software shop here in Germany specializing in process-driven architectures. And I'm just highlighting my company at every talk I'm giving in the Elixir space because I find it really important that our companies support us in what we do. And I think BitCrowd is also one of the really good examples of this. They support us in seeing more Elixir software in the world. And speaking of Elixir software, well, it was all already said. I'm René on Twitter and GitHub, and on GitHub you can find some of the software I created, which includes Credo, which is a code analysis tool, as well as Inch, which is a documentation analysis tool. And this is the one we will talk about today. And in a way, both of these tools were heavily influenced by my time as a teacher. I was working as a part-time teacher during the time of their creation. And I really wanted to talk about documentation again because it is something that is all too often neglected when it comes to software engineering. And this talk will deal with it in 3 steps. First, we will talk about what documentation and especially inline documentation is. Secondly, we will talk about which tools we have to deal with documentation. And thirdly, of course, we will talk about EEP48, the elephant in the room, the new feature in Elixir 1.7. So, first let's define what kind of documentation we are talking about. There can be several kinds of documentation around a project, like a project website, reference materials, how-to guides, tutorials, readmes, and of course, at the core, there's inline docs. And just in case you're not familiar, and because this may be the key teacher in me coming through, I would like to start by clarifying what inline docs actually are. Because it might be clear in Elixir, but that's certainly not true in other programming environments, and I just want to make sure we're all on the same page on this. Normally, inline docs are comments of any structure preceding a function or module or a class in OOP that describe the functionality provided by the documented code fragment. In this case, as you probably already noticed, we just wrote ourselves a node, our future selves, that he or she should do the work of writing some actual documentation. With Elixir, however, inline docs are not comments. Instead, we have a module attribute called doc, which is used to store the documentation string for the following function. There is also an attribute called moduleDoc, which does the same thing for modules. One thing you can notice here is that docs are treated as first-class citizens in Elixir with clear rules. Documentation can be given for modules, functions, including macros and callbacks, as well as types. There is no documentation for private functions for very much the same reasons. For pretty much the same reasons that there are no tests for private functions, because these are implementation details that can and should be easily to change. Let's look at a real example to understand both the meaning and the formatting of docs. In this example, we have a function called size that takes a file name or blob and a second parameter called mode, and it returns the size of this file name or blob. Now, like so many things in our industry, documentation comes in a variety of different shapes and sizes, and in Elixir, we write docs in Markdown. But this is more of a consensus than a norm. You are free to use your own documentation standard inside the doc string. For example, this is TomDoc, which originated at GitHub, and it looks like this. And one thing I always liked about TomDoc when I was programming Ruby was a visibility qualifier at the very start of the documentation string, which said public or internal or private. Because by using internal, you had an explicit way to say this function or method or class, although technically public, is actually part of a private API. So don't use it outside our project or our library. So you could use TomDoc in Elixir, but to be honest, you won't. In Elixir, the way to say this function, although technically public, is actually part of a private API, is to simply set the doc attribute to false, which means this is intentionally left undocumented for the end user. And it shows that there is no intention to document it in the future, and that you should probably not use this function outside the module. Believe me, because I once used private hex functions in Credo, and yeah, Eric wasn't too pleased. The same goes for macros as well as modules. This is great because it follows the principle of least surprise, because explicit is better than implicit. You will never have to say, of course I left it undocumented, you idiot, because you can put module doc false. So, to summarize, we have module documentation as well as documentation for macros and public functions. We have no documentation for private functions for the mentioned reasons. And for more advanced use cases, we can also document types using the type doc attribute, and we can document callbacks by using a simple doc attribute. Now, by now you might think, okay, thanks for the introductory class, but what is the freaking problem? Why should anybody care about this? Well, let me tell you a story. A couple of years ago, I had to document a code base for a university project. That were 5,000 to 10,000 lines of Ruby code. I wrote all by myself, and like always, I never wrote a single line of inline documentation. And faced with a decision whether or not to put in the work to document this code, I was confronted with two very different worldviews on the subject. The first one here I held in my early 20s. And basically, I was convinced that when I was writing code, that was just golden truth flowing through my fingers into the keyboard, and that any programmer worth their salt would immediately understand what I was trying to convey and what my code was trying to achieve. I don't hold that view any longer. And the other, a bit more real-life compatible view is that people are simply not code parsers. In any medium-sized project, solving a non-trivial problem, a comment here or there, just one or two sentences in plain English, explaining why stuff happens goes a long way to onboard a new team member, or even to help your future self who hasn't looked at that code in a year. This does not mean document and comment all the things. It just means explaining why another module was introduced or why the API is structured the way it is in plain English. And as this tweet shows, I'm not alone in having this sentiment. A month ago, Andrea from the Elixir core team tweeted about how he hated this whole, oh, code should be self-explanatory sentiment. And although this is about comments and not documentation per se, the basic thought is the same. Don't explain what your code does, but sometimes explain why it does what it does. So anyway, I decided to document that university project, and naturally I looked for tools to help me with the task at hand, because there must be tools, right? I mean, we have tools in Elixir like Crossref and Credo, and tools for code coverage and penetration analysis and property testing, not to mention the mothership of all Erlang analysis tools, Dialyzer. And there are more and more web services integrated into GitHub now supporting Elixir, like Travis CI, Code Climate, Coveralls, and Dependabot, and many, many more. And don't get me wrong, there were always approaches for analyzing docs. But most of the existing tools fell into one of two categories. The first kind of tools was just looking for the mere existence of code comments, and then were telling me there are 0 lines of documentation. To which I thought, yeah, I know, I'm the one who did not write them. And then there were tools tailored towards a specific documentation format, like JavaDoc or Yard, that would give you a percentage of what you could have done, like documenting parameters, return values, and giving usage examples. But this would lead to the peculiar behavior where you would get something like 65.7% documented on code bases that were documented relatively well, just because you weren't giving a usage example for every freaking method. My problems with this was that these tools were just telling me the facts. But I did not want the facts. What I wanted was opinionated hints where to start. I wanted the software to tell me what to do, and I wanted the software to prioritize for me. And it rubbed me that all these tools either looked for the pure existence of documentation or were specifically designed towards a single format, because such a tool should be able to be independent of the documentation format. So this is a part where I go into some of the key design choices made while implementing both the original Inch for Ruby and the new version for Inch for Elixir. What I like to do is take you on a little journey through the design process of creating a command line interface that tells us what to document next. So how do we start? Well, first let's make up some rules regarding the question, what should be documented and how can we measure that? We want to look at code objects for evaluation, and it's code objects that are modules, functions, and parameters. After we collected these objects, we will have to assess how much documentation there is and assign scores based on our findings. And these scores will range from 0 to 100, with a completely undocumented object getting a 0, and the max score will be 100. But of course, there's a catch, so how do we get the data? Well, fortunately, there's a function for that called getDocs2 in the code module, and it works by using the module that you want to get the documentation for, which is plug builder in this example, and the second parameter for all intents and purposes will always be all. And this is how it works. What you get back, what you can see is that we get the macro information, the public function definitions, you get the module documentation, the callback documentation, and the type documentation. And this is how code getDocs2 worked. And if you did not follow that, that's not a problem because it's deprecated. And that is because the new rage, of course, is Elixir 1.7, and with it, EEP 48. Now, EEP 48 stands for Erlang Enhancement Proposal 48, and it describes a unified storage format for documentation, which is compatible across all Beam languages. To clarify, this still leaves room for individual styles in each Beam language while unifying how all the Beam languages store their documentation. This will allow us to use common tools and libraries across Beam languages in the future, and this means less friction, and that's great. So the new function is called codefetchDocs, and it only takes a single parameter, and you might have guessed it, that's the module you want to get the documentation for. And this is what comes out. It is a 7-element tuple, so let's break it down. First, we have the language. I skipped over the number, the 2. That's just the line number where the declaration starts. So the first interesting thing is the language, which is obviously Elixir in our case. Next, there's a binary describing the content type of the following documentation strings. In our case, this is text markdown, and this can tell the tools processing the given documentation how to handle them. Next comes our module doc, and as you can see, this is now a map of localized strings, and we'll see in a minute how they work, as well as a map containing metadata, which I will also describe in a second. The last element of this tuple is a list, and this contains all the children of the module. Here we have our public function, our macro, and our type information. And for all of those, we have a map of localized doc strings, which can also be atoms, as you see here. Let's see how these are filled. When we provide the doc attribute with a string, a normal doc string goes straight to the English part of the map, which is hard-coded in the Elixir codebase at the moment, but there is a to-do command to allow this to be customized. When we provide the doc attribute with a keyword list of properties, those go directly into the metadata map. And an example of this would be an author key, which would then go right there. And it would also make me the author of this function, which would be gratuitous, I think. So, as you can see, the map of localized doc strings can also be replaced by the atom hidden when we set the doc attribute to false, which tells us, yeah, this documentation should not be displayed. And the atom none when there is no doc attribute declared at all. The same happens for the module's module doc attribute, and these are the properties that are going to make all the difference when dealing with documentation. We know which programming language the docs originated from, which content type they are written in. We can have docs localized in different languages, human languages, that is, like English and French and German. And we can have metadata across Beam languages. So, we wanted to measure documentation. So after fetching the docs from Elixir, we have to cast them into these code objects, and then we have to attach some roles to account for the various properties, and finally assign scores to each, which we can then use to calculate an overall score, which might sound terrible, so let's have a look. This is our example from before. And the roles we would assign to this example are, it has a doc string present. It has also given a code example. One of the parameters is actually mentioned in the documentation and another one isn't. And the twist is we can express these roles, which the documentation for this function has, as tuples. And we can then match on these tuples when assigning scores. And this is how we can easily achieve this. So we take all the roles on a code object and reduce them using the score function into a single score. And then the score function can match on the various items in the role to calculate an overall score. And we can see how this would get a score of 80 for the example on the slide before. So, are we done? Well, there's one thing we did not do yet, and that is to prioritize which things are more important to document than others, which is why we need another set of rules to determine just that. So we make up rules like top-level functions might be more important to document than internal ones. Functions with many parameters might be more important to document than functions without any parameters. And modules containing functions which are probably more important to document than those not containing any functions. Let me show you an example. So looking at this example, we can see that we have three modules: app, app models, and app models user. And the importance of documenting these modules is not the same. There is an argument to be made that the one in the middle is the one least important to document, because it does not contain any functions and it just serves as a namespace for other modules. And the one at the top is probably the most important one because it's a top-level module. Same goes for the two functions, register user and the register function in the user module. Although the second one has more parameters, you could argue that the more top-level one is more important to document for the end user. But I think you get the point. With the help of these rules, we can then determine a numerical priority, just like we did with the scores for each code object. And order the list of all code objects by this value. Here we have a sketched list. This should be the names of some code objects, and you see the priorities on the left. And as you can see in this sketched list, all these priorities are hovering around 0. And what we could now do is cut the list to decide which objects are important enough to be in our first report, like document these first. For example, all with a priority greater than or equal 0. The beauty of this concept is that some undocumented code objects won't show up in our report, but they are not ignored. They are just below the line. And if we would look below the line, we could see that an unimportant function with many parameters is still higher than an unimportant one without any parameters. It's just about their relative position. Thinking about scores and priorities, we turn back to our usual example. And now we get a score which says how complete the docs are, and a priority which tells us if this actually matters. With this, we can finally get going, right? Well, there's one last thing. And that is that I don't like, to this day, the usage of numbers for things like this documentation coverage score. Because when you use percentages, and any kind of number is in the end a percentage, as a means to convey coverage, everybody will always aim for 100%. Nobody sees this 80 in warm fuzzy green. Everybody sees it like this. I did not get the high score. I need to reach 100, and I need to put my initials in some kind of high score table, which is an arcade reference to the younger ones in the audience. So what can we do about this? Well, the solution, at least in my mind, is to use grades instead of numbers. Of course, these grades are just representing intervals of scores, and they are nothing more than buckets. But together with the arrows for priority, they are quite effective at telling you, okay, you did good. Go on and document the next thing. Code objects are graded A, B, C, and undocumented objects are assigned a special grade U. A means this is really good, and Inch can't suggest anything else to do here. B means there was proper documentation found. You don't necessarily have to invest more time here. And C means you might want to take a look because you are referencing a misspelled parameter or something of that nature. But the most important thing is undocumented objects are not necessarily bad. They are not assigned an F because the programmer should decide if he or she wants to document the function. Inch will not demand for all code to be documented. So now we have all the ingredients to finally implement the de facto command line interface. Let me first show you how it would have looked had we used numbers. And we can read it. We see here two sections, properly documented and undocumented. Unfortunately, there is no C grade in this example. On the left is the score, the 80, the 70, the 70, and next to it comes the priority, the 4, the 2, and the 1. And then the name of the code objects in question. Let's have a look at the same picture as soon as we substitute the score for grades and the priority values for arrows. It becomes much more human readable and inviting. It looks encouraging because it tells you, yeah, you did good. And finally, I hope everybody can see this, let's look at the summary at the bottom, where we do show a bar chart instead of an overall grade, because showing a distribution paints a much more detailed picture than an average grade ever could. So we can have an intuitive, accessible, and gorgeous looking CLI, but A little secret of our profession is that not everybody who knows how to code and not even everybody who is employed to write code is also a console aficionado. So at this point, my problem was that I really wanted to reach as many people with this concept as possible. But how can we get people excited about this? And this is why I also created a CI service, which is called Inch CI. It is a web service that can give you a nice summary of your documentation as well as a badge to put into your README. And this is what it looks like. It's visually very different from the other badges that you see on GitHub. Like in the CLI, there are no numbers here. Instead, we have a color bar that looks a bit like a progress bar. Each of the colors works out to one of the grades, and it's no coincidence that the colors A and B are looking very much alike, and it's also no coincidence that the color for undocumented is relatively low contrast to the background. Because it's okay to have undocumented parts in your project, and the badge, just like the command line interface, should not judge. So, this leads me to the final section of my talk, the lessons learned during the creation of Inch. Number one, software is people business. Because software is inherently about people, and more to the point, it's about solving people's problems. And you have to get that and relate to these problems for your software to be truly useful. This is even more important in open source, where there is no money involved and the utility provided by our software to other people stands on its own and is therefore what truly matters. Number two. There are two important rules in open source reminiscent of the first two rules of Fight Club. Number one, you can't do it alone. Number two, you have to do it alone. You can't do it alone because you need users and contributors and people filing bug reports and giving feedback. But as everyone here maintaining a project knows, people don't throw themselves at you to fulfill your vision of a project. And so it's always you constantly stealing away 1 or 2 hours from sleep, weekends, and family time to get that bug fixed and that next release out of the door. And this is simply too hard if you're not passionate about what you're doing. And if you're not passionate about your ideas, then nobody else will be. Which brings me to the last one, number 3, show, don't tell. Share the lessons you've learned. Whenever you come by a non-obvious solution and whenever you solve a non-trivial problem, don't lock that solution inside your head, on your hard drive, or in your company. Show it to the rest of us so we can all learn from your findings. Because none of the things that I presented today were originally discovered or invented by me. We are all just standing on the shoulders of giants. And it's what makes open source this great culture that I very much enjoy being a part of. And if I got you interested in the topic, there's a page in the Elixir documentation on writing documentation, which is really good. And that's all I had for today. Thank you so much.
I like opinionated people. So, questions, we have time for questions.
You mentioned the Ruby version and an Elixir version. I know there are some Ruby people who are interested in Elixir, haven't switched yet on the audience. Do you maintain both projects, or Ruby versions are dying slowly?
I'm not sure what you're asking. So the Ruby version is like, it's feature complete. In my mind, so I think the last bug I fixed was around Christmas last year, where there had been some delay, so I wasn't as responsive as I should have been. And the Elixir version was originally just sort of a front end for the Ruby gem, and that now changes because now on master we have the first release candidate for Inch 2.0, which is completely written in Elixir, for Elixir, which allows us to do all this nice stuff like matching on tuples to identify things that give scores.
So the plan is to have both.
Absolutely. It's one of the reasons why I wanted to start giving talks again about this. I know you were at the original announcement like 3 years back or something, and I have neglected the whole topic a bit because, quite frankly, the success of Credo has taken up all the last bit of free time I have left after switching jobs, after getting a real job.
Why don't you take the number of calls to a function as a measure for priority? A function that is called lots of times is an important function for the document.
Yeah, that comes up at every discussion about Inch, and I think that would be the way to go if I would get to invest more time into it. But you also would have ideally to collect something like usage data, so profiling of the functions and which are actually called often in production. It might be easier in Elixir because of the static analysis we can do right out of the gate, just like Credo does it. With a Ruby one, I had the problem that in most projects, there's so freaking much metaprogramming going on that you can't determine how often a function is called without running it. And then people are saying, okay, then just look during the test suite how often a function is called. And that might be a measure, but I just did not have the time to work out all the details on that. But I would be very open to discuss that afterwards.
Any other questions from the audience? I have a question actually. Yeah, so actually about inline documentation in general, how do you guarantee it being in sync, right? Because it always goes out like outdated from the actual code.
And the answer is pretty simple. You don't. So I think since becoming a team lead at a larger company, we're about 60 people, one thing I learned is you can't replace something like craftsmanship. So people have to be proud of their work, they have to have an interest in their work being good, and I think inline documentation is the one kind of documentation where we have a chance of keeping it in sync without employing a separate department to do the documentation stuff. But at the end of the day, if you look at open source projects, there are always pull requests saying, oh, look, that parameter name changed and you guys did not get that. And I think that's okay.
Any more questions? We still have time. No, thank you so much.